Here is an indefinite integral that I want to compute. I want to find this antiderivative, and it turns out that this guy is a really good candidate for trigonometric substitution. That x squared plus 4 squared, you're going to make the x equal to 4 tan theta, and that means that dx is equal to 4 secant squared theta d theta. And you make those substitutions. See how I substituted the x up top and on bottom, and that dx blows up into all of this stuff. And then I'm going to start simplifying. And so there's a couple of things that I'm doing here. So first of all, there's 3 times 4 times another 4 that turns into 48. And I have a tan theta and a secant squared theta up top. And on bottom, here's what happens. Do you see how this is 16 tan squared theta plus 16? Well, I turned that into 16 secant squared theta because of this trig identity. The next thing I'm going to do is factor out this 16 from under the radical, which turns into a 4, and I'm going to simplify even further. And so on top I have 12 tan theta secant squared theta. Now the square root of 16 secant squared theta is, the square root of secant squared theta is the absolute value of secant theta. But what we have here is that the secant of theta here is always positive because of restrictions on what theta is going to be. And so that means that those absolute value bars fall away, and the secant on the bottom cancels with the secant on the top, and I get the integral of 12 tan theta secant theta d theta, and that's fantastic because I know exactly what that's supposed to be. It's 12 secant theta plus c, but I'm not done. You're not allowed to have your solution in terms of theta. So we got to bust out a triangle. Here's the relationship between theta and x, right? Because x is equal to 4 tan theta. And so then you need the hypotenuse. It's the radical of x squared plus 16. And that means that the secant of theta is equal to radical x squared plus 16 over 4. And that means that the solution is 3 times radical x squared plus 16 plus c. That is a valid solution technique. But I do want to point something out. You have x squared plus 16 on the bottom. You have an x up top. That means that you can set u equal to x squared plus 16, which makes du equal to 2x dx. And this integral turns into 3/2 du over radical u, also known as 3/2 u to the minus 1/2 power du. This integral is very easy to do. You get 3u to the 1/2 plus c, and you back substitute, and you get the solution. So what I'm trying to say is, at no time will you ever lose points for choosing a less efficient method. There's nothing wrong with doing trig substitution here. And I don't like to ask questions that say, determine this indefinite integral using a specific technique. I want you to choose the technique. So you would never lose points for choosing that less efficient method, but look how much easier it was this way. So it's a good idea for you to think about when it's best to use the various methods, or to have a very well-defined routine in your mind when you walk into an exam saying, well, you know what, first I'm going to try substitution and see if that works because that doesn't take much time. And if I have to do that, then I'm going to try something else, trig substitution or whatever. So, yes, definitely organize the techniques in your mind and have a routine in place for which one you're going to do first.